By the end of the lesson, I expect you to be able to answer this question. Now let's talk about what I mean by SSS and SAS. And then we'll talk about how we apply the cosine rule in practice. So an SSS triangle is when we have three sides given to us in the question. So we would have something like this. This side would be labelled, this side and this side. This means we would have to use the cosine rule. This is an example of the cosine rule. Whereas for SAS, we would have a side given, an angle, and then a side. The order of these letters are important because the A means that it is in between both two sides. So we have a side here, and then we have an A encompassed in between the two sides given in the question, and then the A in the middle. Whereas the sine rule is a lot different. The reason why a sine rule is a lot different is because we have a side-side angle. So that would be, for example, a side here, and then an angle here. Whereas an AAS would be an angle. So this could be an angle, and then a side, and then finally an angle, side, angle would be when we've got an angle here, a side here, and then an angle at the top. So make sure you know the difference between side and side angle side and all the different sine rule ones as well, so you know at the beginning of the question whether you're going to apply cosine or sine. Remember, you can apply cosine for most of these different triangles. However, it's always easier to apply sine, and you'll see now why. So let's have a look at these triangles. You can see these two triangles are a specific type. They're either SSS or SAS. Pause the video and have a think of what they are. Welcome back. Hopefully you realise they are both side, side, side. As in this particular question, we are required to find an angle given the three sides already. So what we need to start off with is one of the cosine rules. So when you want to find an angle, it's good to use the cosine rule where you have cos of an angle on one side, and then you have the rest of the letters, which are lowercase letters, on the right hand side. In these problems, we need to think of the capital letters as the angles, such as the angle at A, the angle at B, and then the angle at C, and the lowercase letters are going to be the sides opposite the angle. So lowercase a would be represented by the side opposite to angle A, which is 12. Pause the video and have a think of what lowercase b and c are. Hopefully you realise lowercase b was 10.5 and therefore lowercase c is 15. Now you might think, well, what is the difference between these two equations? Well, what's happened is for this equation on the right hand side we have less negatives, and this is the typical one you'll be given in the exam. So we have c squared plus b squared minus a squared divided by 2bc. But all of these terms are exactly the same as these terms on the right, but each single one of the terms has had its sign changed. So the negative a goes to positive a, the positive b goes to negative b, the positive c goes to negative c, and the positive denominator has been changed to a negative denominator. And effectively what happens when you change all the signs in a fraction, the answer becomes the same. It's a bit like saying, what's 1 divided by 1? Well, that's going to be 1. This would therefore be, what's minus 1 divided by minus 1? Well, that's also 1. So if you change all the signs in a fraction or something like that, you are going to keep the answer consistent. This is why we don't need to change the left-hand side of the equation. Now let's get on with the question itself. All you need to do is substitute the letters in. And because this is a side-side-side problem, it doesn't really matter which way you substitute it in. What I mean by that is it doesn't matter how you label the triangle A, B and C. Because this triangle is already labelled with the letters A, B and C, it makes sense to keep those the same. So A we're going to replace with 12, so we do 12 squared, B 10.5, C 15. And we just substitute this into the calculator. What I would recommend you do is work out the numerator first on your calculator and then divide it by the denominator. You do not want to make a step error in the final few steps of the calculation. What we get then is cos A is equal to this, And then to get A on its own, what do we need to do? Pause the video and have a think. Excellent. We need to find the inverse of cos. So the inverse of cos in this instance, making sure your calculator is in degree mode, not radian mode, is going to be A equals cos to the power of -1 of 0.6714, etc. is going to be 52.6. Now, here are a few more questions on the screen. You can see they are all side. So I'd like you to pause the video and have a go at these 4 examples. So if we have a look at the answers to these 4 questions, you will find the following. Next up, we're going to have a look at a diagram which shows you how and when to use the sine, cosine, trigonometry and Pythagoras rules. So let's go into the diagram. Let's look at the first question. Is it a right angled triangle? So the key thing you've got to remember is with cosine and sine rule, we are not using a right angled triangle, but for trigonometry and Pythagoras, yes, it needs to be a right angle. What we need to decide is, first of all, is the problem to do with angles at all? And if it's not, it's simply Pythagoras. If you need to find the hypotenuse, we need to use addition in Pythagorean theorem. And if we don't need to find the hypotenuse, we are going to use subtraction. Whereas for trigonometry, we've clearly got to use SOHCAHTOA. There are different things we are going to be using in SOHCAHTOA. First of all, if you are finding the missing angle, you are going to use inverse or arc. Whereas if you are not finding the missing angle, you are going to use multiplication or division to find the missing side. So let's just add a final bit of information, yes and no, which would be here. So you can put a letter Y and a letter N. And now you might like to screenshot the screen so you can refer back to this diagram in another time. Continuing on then, we're going to talk about why would we use the sine and the cosine rule. If you need to find the area of the triangle, we need to use this rule, which we're going to talk about later in the video. But if you don't, we are going to decide, is it an AAS, SSA or ASA triangle? If it is, we are going to use the sine rule. If it isn't, we're going to use the cosine rule. Another way of thinking of this is in terms of triangles. So remember, in the problem, if we're given to begin with a side and then an angle, and they both match together, as in we have the side opposite the angle, we automatically use the sine rule. If this is not the case, i.e. we have got a side, we've got an angle, and then we've got a side, this is a SAS triangle, therefore we need to use the cosine rule, and we cannot match any angle with any side given in the problem. I hope that's starting to make sense to you. So what we need to think about is, if we are using the sine rule, do you need to find the missing angle? If you do, we need to put the angles on top. So it's going to be sine A divided by A equals sine B divided by B equals sine C divided by C. If we're not, we're going to have the sides on top. So we'll have A divided by sine A equals B divided by sine B, etc. And then last but not least, we need to use the cosine rule for any other types of triangles. So we've discussed mainly the SAS triangle and the SSS triangle, but of course you can also use the cosine rule for these triangles as well, but it's not as easy. If you'd like to copy these rules down, I will put them on the screen shortly. Now let's go on to an actual cosine problem. We're going to use either this equation or this equation, so let's copy this over. These are the 2 equations we want to use, and we'll talk about why we would use each during this problem. The first thing we need to do is calculate the length of AC. So let's identify what AC is. AC is the distance from A, which is at a vertex, to C. So I'm going to study the left triangle and the right triangle. In terms of the left triangle, we have 2 bits of information, and the right triangle we have 3 bits of information. For the cosine and sine rule, we need 3 bits of information, so we're going to use the right hand side triangle. I'm going to identify what kind of triangle it is. So let's have a look. Side, angle, side. It's a SAS triangle. So because it's a SAS triangle, we are going to apply the cosine rule. In terms of this, we would like to find a missing side. So we're going to use the first formula. Before we start, we're going to decide whether we're going to be changing the letters of the equation or the letters of the triangle. I think for this problem, I'm going to change the letters of the equation. So for this problem, we want to find out what side B is. So wherever there's an A, we switch to a B, and wherever there's a B, we switch to an A. So I'm going to do a little bit of a note here so we remember to copy it out properly. So I'm now going to copy out the equation on the right hand side, but this time I'm going to substitute the correct letters. So we know that B squared, which is the length of B squared, obviously, equals A squared plus C squared minus 2AC, making sure we're following the blue lettering, cos B. You can see my writing here is top notch. So let's substitute in the relevant values. Obviously we don't know what B is, so we're going to carry on, write B squared. A squared is going to be whatever A is. So our A for this is going to be opposite the angle A, which is going to be this side here. So we're going to have 9 squared. C squared is going to be the other remaining side that's given, plus 12 squared. It doesn't actually matter what order you put 9 and 12, because you can see that these will be partnered up together. In every part of this equation, we have A squared plus C squared minus 2 lots of AC. Basically, they are doing the same job, so it doesn't matter if you swap them round. The only thing that you can't swap round is the B, because the B is to do with the angle we are trying and the side we're trying to find. So we then need to do minus 2 times 9 times 12 and then times cos B. In a moment, we're going to talk about how we would type this on the calculator. I would simplify this up a little bit to make it a little bit easier. So 9 squared is 81, 12 squares is 144. And then adding those together, quick maths, we've got 145 plus 80 is 225. So we've got 225, 9 times 12 is going to be 108. And then we've got 216 minus 216 cos B. This looks pretty simplified to me. So we need to make sure that we put the angle in, which is 93, and we're ready to get the calculator up now. So let's have a look of how we would type this into the calculator. So minimising and then therefore maximising the calculator, we can get the following. So we're going to go on to just the normal calculator mode for this one, nice and simple. Because we want to find B, I'm going to do this all in one step. I'm going to type in the square root. The square root's above the x squared, so press second x squared, and then we're going to type in, as we see fit, this equation here. 225 minus, remembering we are using the large minus, 216 cos of 93, close brackets, enter. Now we get the correct answer. Our correct answer should be 15.3722. Now, for part A, we are going to apply similar principles. So we need to have a look at how we would find the length of CD. So CD this time is going to be in the left triangle, not the right hand triangle. So we must just apply our knowledge to the left triangle. Let's do that now. What I'd like us to do is to label the sides appropriately. So we are given a side, we're given an angle, and we're given a side. This means we must use the cosine rule as before. We're going to use this because we want to find a missing side. So our missing side, coincidentally this time, is going to be side A. So we do not need to change the A's in the equation. In terms of the B's, there are no B's, so we're going to change the D into a B, and the C's can remain the same. So let's substitute in our relevant values. Taking the equation A squared, we want to find this, which is the unknown, so we're going to keep that in the equation. A squared equals B squared plus C squared minus 2BC cos A. What you will notice in these equations is, regarding the way you rearrange them, two of them will be paired off together, which means whatever one does, the other one does as well. So if we're having b squared, we will also add ac squared, and this is if the problem is to do with finding a, whether that be angle or side A. Similarly, if we're timesing by B, we'll also times it by C. So it doesn't actually matter which way round we write the B's and C's. That's a fine detail that you might find useful. So we're going to write down the two missing sides squared and then add it together. So we're going to have the following 15.37, and I'm going to put a few dots here to represent the fact that we're going to square the whole number. The more decimal places you're squaring, the more accurate your answer will be. Minus 2 times 7 times this number we haven't yet rounded. And then we're going to do times cos of the angle times cos of 68. Now, we can actually do this in one step in the calculator. If you're not sure how to do this, I wouldn't recommend this. So grabbing the calculator then, we are going to see if we can put it in one step. But as you've seen before, I made a small error. It's very likely that you will. So to find a, we need to find the square root. So let's type that in. But before we do that, let's quit from this. And let's go back to the previous answer. So let's say we got the previous answer from the previous question already, and let's talk about what we can do with it. We can actually store this into the calculator. So let's take the cos of 93, press enter. Here's our 15.3722. We're going to store this into the calculator, and the way you do this is you look for the store button. So this is like putting it into a shop. So we press the store button, which means we want to put this number 15.377 somewhere. Now, you can put it in lots of places, but the best places to put it are these green letters. So Y, Z, theta, V, U, T. And because they're on the right-hand side and because they're green, in order to store them, you have to press the green alpha button. Let's store it into Y. So press alpha and then 1. So on our calculator, it will say that the answer, which is this, is going to go into Y. Press enter. Now we can recall that whenever we want to. So we're now going to go back to finding out what A is. So we need to find the square root. So we're going to press second square button. So we get the blue option, which is the square root. 7 squared. Then we're going to put plus whatever we stored into Y squared. So to recall it, you have to press the blue button here, second store, and then to get the Y up, we have to press alpha 1. So it's 4 buttons we have to press if we want to recall it. We want this number squared minus 2 lots of, and because we're doing a multitude of things multiplied together, I'm going to put them in brackets. 7 times, again, we want to times it by Y, so we're going to recall it. Second store alpha 1, enter, times by cos of 68. And now when I was doing this problem before doing it on camera, I had made an issue with this, and I'll explain exactly what I did in a moment. So our answer here, lovely. If you type it into the calculator properly, you should get this answer, which is 14.3068272. But before you ever do any of these problems, you need to check the mode of the calculator. And what you need to check is that the mode of the calculator is on degree. In this course, we will not be using radians, so make sure you press enter for the degree. So this is the answer to part B. Now for part C, this is fairly straightforward, and we're going to talk about why. Part C, you can either use the cosine or the sine rule. This is because we are now given the side, the angle, the side, and another side. So if you wanted to find out the size of angle ADC, which is this angle here, we could apply side, side, side rule for cosine and work out the missing side. For that, we would use the formula I briefly alluded to at the beginning of the video. You would use this formula here. And what you would do is you would substitute in c squared plus b squared minus a squared is 2bc. So we would talk about this time A being the angle we want to find, which is this angle. So we switch A and B round. And the way we would do that, we would call this one A. Therefore, this would be side A. Now, this is switching the triangle rather than the equation. This would be B, capital B. Therefore, this is side B. This is lowercase c. Therefore, this is angle C. So we're switching the D for the A for the B, and then a problem matches this equation. And then we would just replace the C, the B, and the A, the B being part B, ironically, into this equation and using this rule. However, what we're going to do this time is using the sine rule, and I'll explain why I think the sine rule is superior. Putting some information into the triangle that we've already found, we now know that this side is 14.3 with a few more decimal places. And should we ask ourselves, do we have a matching pair and a matching side? And indeed we do. We have a matching pair and a matching side. So because we have this angle and side, we're going to use the sine rule. We could then use either side to find the missing angle. So for example, say if we weren't given this side in the question or in the exam, we could use the 7 to find the angle at C, and then using the angle at C, the angle at A, and the fact that these three angles add up to 180, we can then find out the angle at D. It doesn't actually matter what is the second side given for the sine rule, because you can always use the information you glean from the angle to find out the other missing angle if the question is to do with angles. So the sine rule means that we want to find an angle for this problem, so we're going to put the angles on top. So we're going to do sine of 68 over 14.3 equals sine of the angle at D, or more technically the sine of ADC. And the reason why it's called ADC is because it joins sides AD and DC together is the angle which joins all three of those sides together, divided by the side opposite it, which we are thankfully given in the exam because we've already worked it out. Remember, if you didn't get this right initially, you will get method marks, and you could get full marks for this question even if you've got these two numbers wrong. So worst case scenario is you guess these numbers in the previous question and then you substitute it in for the last part to get your marks in question C. And then substituting that in, this is relatively straightforward, and whenever you're talking about the sine rule, this method will always work, but it's best to understand why. We are going to take the equation, which is at the bottom of the screen here. We want to get ADC on its own, so we're going to eliminate the denominator by timesing both sides by this denominator. So let's type this in. We're going to get the denominator of the right-hand side onto the left-hand side. And remember, when we're moving something from the denominator, on the other side it becomes the numerator. But we also want to find the inverse of sine ADC. So we're going to press second sine, then we're going to type in 15.37222011. And remember, it doesn't matter which order we put these in terms of whether we do 15 times 6 sine 68 divided by 14.3, or if you do sine 68 divided by 14.3 times by 15.3. Basically, because we're timesing and dividing, these are commutative, which means you can switch them round. 6 times 3 divided by 2 is the same as 3 divided by 2 times 6. So then we're going to times by sine 68. And then last but not least, we're going to divide by the final number, which is 14.306, keeping as many decimal places as we can, and then only rounding in the very last part of the question. Pressing enter, excellent, 85.021. Let's now do a sanity check to see if this seems like a good enough answer for us. So we are going to put the answer at the bottom of the screen, and we're going to talk about it in terms of the context of the problem. In terms of this problem, we're going to say that this angle here is 85. That makes sense. It's a relatively normal angle. 85 plus 68 is less than 180. And it looks right in terms of these sides. What you could always do is do a quick sketch in your exam, just see, is that logically correct? For example, if it was going to be 22 degrees, you might be a bit surprised by that answer because these would add up to just 90 and that would have to be 90, and that could be the case, but that's quite unlikely for this problem, especially as this problem's not set up to be to do with a right angle triangle. Now what I'd like you to have a go at is finding A in this problem, A in this problem, finding all the missing sides in these two problems, and finding B and C in the last problem, E and F. I hope you found this video useful, and let me know if you've got any questions.